we're going to start rational expressions, which is 1.4. Okay. Now, okay. All right. So 1.4 rational expression. Rational expression. Okay. So what we'll do is I want to skip the domain of rational expressions. We will multiply and divide rational expressions. So multiply and divide rational expressions. All right. So number one, this is actually number 19 from the book, is x squared minus x minus 12 divided by x squared minus 9 multiplied by 3 plus x divided by 4 minus x. I'm very sure you remember this. Yeah. So I will just do one multiplication and one division. And then we have 4y squared minus 9 divided by 2y squared plus 9y minus 18 divided by 2y squared plus y minus 3 over y squared plus 5y minus 6. Oh, by the way, I was told that the Textmania sells MathXL. Did anybody check Textmania? It's $39 or $40 in Textmania. Yeah, I was told. And okay, so anyway, let's start. And I'd like to see everybody log into MathXL and do the 1.5 by 1 by Saturday. Yeah. Okay. Because Sunday is the last day to drop with a W, right? So, so if I don't see your name on the list in MathXL, I would like to exclude the students. All right. So, number one, what should we do here? Are we multiplying now? No, we're factoring first. So x squared minus x minus 12.
So x minus 4 equals 3.
Yes, that's right. Divided by x squared minus 9. Yes. So x plus 3, x minus 3. You're right. Multiply by 3 plus x. 3 plus x is x plus 3, isn't it? So I'm just going to put 3x plus 3. 4 minus x. 4 minus x is 4 minus x and x minus 4, are they the same? No. So this is negative of x minus 4. So this is the opposite of x minus 4. Yeah. So let's cancel common terms. So x plus 3 cancel. What else cancels? X minus 4. Okay. So on top you'll have x plus 3, and on the bottom you'll have negative of x minus 3, but we will put the negative on top or in the middle, so like this. Yeah, so negative of x plus 3 over x minus 3. Or the other option would be to write it like this. Negative of x plus 3 over x minus 3. So notice that 4 minus x and x minus 4 is the opposite. Yeah. So if I have, so note, 4 minus x is negative x plus 4, which is negative of x minus 4. So you're saying that 4 minus x and x minus 4 are opposites. All right. They're opposites. Yeah? So 4 minus x is the opposite of x minus 4. Okay, good. Now, how about number 2? Well, can we factor out 4y squared minus 9? Oh, this is division also. Right? This is division. What do you do with division? Yeah, you have to flip it. So you could flip it and factor it at the same time. Okay. So 4y squared minus 3. What minus that? What 9? What is that? 2y plus 3. 2y minus 3 divided by. Oh, now we're going to factor out 2y squared plus 9y minus 18. So I'm going to do. Write it on my scratch. All right. Scratch. So how do we factor this? Do you remember? AC. So 2y divided by 2. Right? Okay. So what is the product? Negative 36. Yes. What is the sum? 9. So what are the two numbers? Is it factorable? 12 and 3. And you have to adjust the sign. Negative 3. All right. So if we multiply, this is negative 36. If we add, that is 9. So minus 3 plus 12. All right. Good. How am I splitting up the 2? 1 and 2? Yes. So this is 2y minus 3 times y plus 6. All right. Cool. Are we okay so far? Yep. Okay. Do you remember the AC method? Yeah. So it always works if the expression is factorable. Yeah. It always works. Now, this is where we have to flip. So I'm going to put y squared plus 5y minus 6 on top. All right. So let's factor out y squared plus 5y minus 6. So what is this? Yeah. Y, what did you say? Y plus 6, y minus 1. That's right. So not y plus 2, y plus 3. Yeah. Now let's factor out 2y squared plus y minus 3. So this is my scratch again. So what method? AC? Okay, or trial and error. I think this is easy trial and error, but you can use AC. 2y divided by 2. So product is equal to negative 6. Sum is 1. So what are the two numbers? Negative 2 and 3. So when we multiply, this is negative 6. When we add, this is positive 1. So minus 2 plus 3. All right. How are we splitting up the 2? 2 times 1? Yes. So what's my answer? Y minus 1 times 2y plus 3. Yes. All right. Are we okay so far? The AC method works? Yeah, AC method's not that hard. Okay, now, what do we do next? We cross-cancel common terms. So which ones are common terms? Y plus 6, y minus 1, what else? 2y plus 3, oh, all of them? So what's your answer? Yeah. Wow, after all this work, we have a 1. Okay, good. Now this is in your scratch, so we will erase this actually. Yeah, so these things should be done on your scratch. This part right here. So actually I'm supposed to erase it. Yeah, so my work is just this line up to equals to 1. This is our scratch. Yeah. All right. So easy? Okay. Now, we're going to add and subtract rational expressions. So B, when you finish. Okay. B, adding and subtracting rational expressions. All right. So you have to find the LCD first, right? As usual. So for example, what if we have 1 over x plus 3 plus 1 over x squared minus 9. So I'm adding. Okay. And then number 2, maybe I'll just do number 2 here. 1 over x squared plus 3x plus 2 minus 1 over x squared minus 2x minus 3. So this is not an equation, this is an expression. So we have to find LCD. All right. Okay, so what is the LCD here? So we are going to factor x squared minus 9 first. So let's factor out x squared plus 9, minus 9, sorry. What is it? Yes. Good. So what is my LCD? X plus 3 times x minus 3. So we're going to rewrite both using the LCD. So the LCD is x plus 3, x minus 3. X plus 3, x minus 3. Right? All right. That's my LCD. So LCD is x plus 3, x minus 3. Yes. Now, now what? So this is x plus 3. This is x plus 3, x minus 3. So I need to multiply by x minus 3 over x minus 3. So I'm multiplying by 1. So we're always multiplying by 1, so because we don't want to change the value. So the 1 has the form x minus 3 times x minus 3. Okay. All right. So on the second one, we already have the LCD, so we just copy this one. So what next? So this is, we have a common denominator. We could just add the numerator, x minus 3 plus 1. What is x minus 3 plus 1? Yes, x plus 3, x minus 3, and we finish. Yeah. So we leave answer in factored form. So leave answer in factored form. So we don't multiply x plus 3 times x minus 3. So we will just leave it in factored form. Yeah. All right. So we don't multiply out x plus 3, x minus 3. Can you guys try number 2? Really quick? All right. So who came late today? I recall. What's your name? Edgardo. Last name, Edgardo? Okay. Were you here yesterday? No, okay. And your name? Last name? Okay. All right. Okay, hold on. Jack? And then here, Alex? Zen, right?
Yes.
Okay. And then next line, I think, Jose, what's your last name? Ion. Okay. Late. And then next row, Brittany? Phillips? Were you here yesterday? No, right? Okay. And then Isabel? Okay. Who else in the next row? Nobody came in here? How about this? So, Kevin? Everybody's here today. No, Fernando is not here. And Jacob's not here. But everybody else is here. Josue, is Josue here? No? So only Josue is not here. Fernando and Jacob. Let's see. Yes. Yes. Everybody else is here. So we have enough seats, right? So, yeah, we do. What is the LCD for number 2? Right. Okay, so why don't you work on it a little bit? And then we will do complex fraction. Okay, so let's work on these. What is this? Factor out. X plus 2, x plus 1. Okay. What about the other one? X minus 3, x plus 1. So what is the LCD?
X minus 3, x plus 1.
Yeah, x plus 2, x plus 1, x minus 3. Okay, so let's rewrite them in terms of the LCD. X minus 3, x plus 2, x plus 1. Yes. This is x minus 3, x plus 2, x plus 1. All right, so what's missing on the first term? X minus 3. So here you have 1 times x minus 3. That's why it is x minus 3. What's missing on the second one? X plus 2. So negative 1 times x plus 2 is x plus 2. But remember, this is negative. So you have to be careful, this is negative. This negative applies to x plus 2. All right. So now, combine like terms. We have the same denominator. We could combine like terms. X minus 3, x plus 2 times x plus 1. What about the numerator? X minus 3 minus x minus 2. So you have to distribute the negative. So it is negative of x plus 2. Yeah. So be careful, this is negative. Yeah. So this negative applies to both x plus 2. So it's negative x plus 2. That's why you have negative x minus 2. Are we okay? Okay. So last step, what do I have here? Oh, the x cancels. And what do I have? Negative 5 divided by x minus 3, x plus 2, x plus 1. All right, we're done. Yeah? Are we okay? Continue? All right, so let's see. Simplifying complex fractions. Yeah, so this is adding and subtracting rational expressions. So what do we do? So find the LCD first, right? Find LCD first. So on your first one, your LCD is x plus 3, x minus 3. What about on your second one? Oh, we already have it here. So next, simplifying complex fractions. Ready? Simplifying complex fractions. Complex fractions. So there are two methods. So method 1. So there are two methods. Rewrite the division as multiplication with the reciprocal. So I'm going to put a big note here. Note, this is easier if the numerator contains one term and denominator contains only one term. Contains only one term. So we use this method only if the numerator contains one term. So both numerator and denominator contains only one term. Because otherwise it's easier to use method 2. Yeah. So method 2. Find the LCD of all the denominators and then multiply each term by the LCD. All right. So note, method 1 is easier only if the numerator contains one term, the denominator contains one term. Because otherwise, it's difficult. It's easier to use method 2. Yeah. Complex fraction. So I'm thinking about something like this. All right. X over y minus y over x divided by 1 over x squared minus 1 over y squared. So something like this. Okay. Okay, so now, which method is easier for this? Method 1? When is method 1 easier? Okay, so you have, do I have one denominator and one numerator? No, so method 2 is easier. Yeah, because otherwise you have to combine these, you have to combine these into one term, and then rewrite it as multiplication. Yeah, so you could use method 1, but what you need to do is combine these as one term, combine these as one term. Look at these, these are 2 terms. Okay? So if you use method 1, you will do more work. Okay? So when is method 1 easier? When you have one term on top and one term on the bottom. So for example, if I have a over b divided by b squared over c, this is one term on top, one term on the bottom, then we could use method 1. Yeah? So here I have 2 terms on top. I cannot use method. Oh, well, I can, but it's harder. So what I'd like to do now, maybe I'll write an example here. The a over b. A over b divided by b squared over c. So this is one term. So you know what I mean by one term. And then this is one term. So for this problem, this is easier if we use method 1. So for these problems, yeah. Now, what is the LCD? So we look at all the denominators. So y, x, x squared, y squared. So we look at all of them. What is the LCD? Yx, x squared, y squared. What is the LCD? X squared, y squared. So I will multiply the top by x squared and the bottom by x squared. So I'm multiplying by x squared over x squared, which is 1. Okay? All right. So now I'm going to rewrite them separately. So you have x over y minus y over x divided by 1 over x squared minus 1 over y squared. And I will rewrite the multiplication separately. So x squared times xy. Oh, x squared y squared. I forgot. What did you say the LCD was? Yeah. X squared y squared. Oh, I forgot the x squared y squared. So then I have x squared y squared times the first term. Here I multiply by x squared y squared. On the bottom, same thing. And this one is x squared y squared. All right. So when I multiply, what do I have now? Which one cancel? The y. So we have what on top? X cubed, y, that's it. Right? Okay. Minus. Yes, so the x cancel, one of the x's cancel, so you have x y cubed. All right, so that's what you have on top, and then this is over 1 over 1. We don't write the over 1. Okay, this is x cubed y over 1, xy cubed over 1, but we don't write it. All right, what about the bottom? So the x squared cancel, so y squared times 1, y squared over 1, we don't write over 1, minus x squared. Okay. So I think we could still factor this. Can't we? Okay. So how do we factor this? X, y times. Okay. Oh, and then you say, oh, this is x squared minus y squared, and this is y squared minus x squared. What is the relationship between those? Oh. Opposite? They're opposite. So if I cancel, what do I have? -1? All right. So hold on. Okay. So when I cancel, I have -1. Yes, they're opposite. So when I cancel, this is -1. So what is my answer? Negative xy. Yeah? Okay. So this one looks complicated, but once you multiply with the LCD, it's good, right? It's no longer complicated. Yeah? Okay. Now, the second one. So this is calculus. Very common in calculus. Are you guys ready? Yeah. All right. So number 2. This is calculus. 1 over a plus h minus 1 over a divided by h. So simplify this. And then number 3, x plus h to the -3 minus x to the -3 divided by h. So the derivative, when we simplify the derivative, we use this, but only the beginning. So we don't do this all the time. So the derivative of 1 over x is limit as h goes to 0, etc., etc. All right. So are we going to use method 1 or method 2? Method 2, why? Yeah, 2 terms on top, so it's easier. What is the LCD? H time, oh, h is not a denominator, is it? No. What's the denominator? A plus h and a. So in this case, the LCD, we could write here, the LCD is a plus h times a. Right? Okay, so I'm going to copy this again. So 1 over a plus h minus 1 over a divided by h. So my LCD is a plus h times a. A plus h times a. A plus h times a. That is my LCD. So I multiply each one of them by my LCD. All right, so what am I left with when I multiply these? Oh, so the a plus h cancels, and I'm left with a over 1, but I don't write the over 1. For the second one, what cancels? A. So I'm left with, but I have a negative here, so negative of a plus h. All right. Now, what do I have on the bottom? Let me see. We should just leave it in factor form. So a h times a plus h. So we're not multiplying them out. All right. Bless you. Are you okay so far? Okay. So now, what is a minus a plus h?
A minus A minus A.
Yeah, which is negative h divided by ah times a plus h. All right. Then what? The h cancels, right? So this is negative 1 over a times a plus h. Okay. Okay. Yes? So will you see this? Yes. 2.5 in calculus 1. Section 2.5 or 2.4. So basically, how is this related to calculus? You're trying to find the derivative. So what is f prime of a? So given f of a is equal to 1 over a. What is f prime of a? So you have to take this is limit as h goes to 0. So this is the 1 over a plus h minus 1 over a divided by h. So what we're calculating is this part right now. Yeah. So we're calculating this part. But this is how it relates to calculus. Yeah. So you'll see this. Don't worry. Yeah. Now, what about number 3? This is also calculus. So I'm going to put this. This is calculus. So you got to pay attention because you're going to see this. All right. What is x plus h to the negative 3? How do I write these actually? 1 over x plus h cubed. Yes. Minus 1 over x cubed divided by h. Yeah. Okay. Are we using method 1 or method 2? 2 still? Yeah. Okay. What is the LCD? X plus h cubed multiplied by x cubed. Yes. Okay, so let's do it. Oh, this is a little bit longer. Yeah. So the LCD, let me write the LCD here, is x plus h cubed times x cubed. Why don't I just write x cubed times x plus h cubed? Okay. So x cubed times x plus h cubed. X cubed times x plus h cubed. And then the denominator also x cubed times x plus h cubed. Okay. All right. So now x plus h cubed cancel here, and the x cubed cancel here. So what am I left with? X cubed minus x plus h cubed divided by, what about on the bottom? hx cubed times x plus h cubed. All right. So now, what are we going to do? Can we simplify the top? What is x plus h cubed? Oh, we discussed this yesterday. We talked about a plus b cubed. Okay, so minus, remember the minus. So I'm going to expand this. What is x plus h cubed? No, we're using the formula that we have yesterday. What is a plus b cubed? A cubed plus 3a squared b plus 3ab squared plus, okay. So we are going to expand this. So what will I have? X cubed plus 3 times x squared h, that's right, plus 3 times x h squared plus h cubed. Yes, that's right. Divided by h x cubed times x plus h cubed. All right. Okay, so let's see. How do we simplify the top? The x cubed cancel, but what are we left with? Positive or negative? Negative 3x squared h minus 3x h squared minus h cubed divided by h x cubed times x plus h cubed.
Wait, which x cube is going to be canceled?
This x cubed and this x cubed. So this is x cubed minus 3x squared minus 3x squared. Yeah, right? Yeah, I just don't write it down because it's too long. Isn't it?
Mm-hmm.
Yeah, so a lot of things need to be done on our head, right? Like this, we're supposed to take out the parentheses. So if we take out the parentheses, what's going to happen? Yeah, that's why I have negative 3x squared. And then where does the x cubed go? Well, it cancels with this x cubed. So x cubed minus x cubed. Yeah. Now, can we cancel anything else here? Yes, we cancel the h. So if we cancel the h, what do we have? Negative 3x squared minus 3xh minus h squared divided by x cubed times x plus h cubed. So maybe I should write this. Divide by h, divide by h. So we cancel out the h. We cancel out the h. Right? Okay. So how is this related to calculus? It's the same thing. So you have f of x is equal to, what is this? 1 over x cubed. And then you want to know what is the derivative. Find f prime of x. So f prime of x is limit as h goes to 0, 1 over x minus h cubed minus 1 over x cubed divided by h. So this is what we're calculating. Yeah, so in the beginning of calculus, I know you know the derivative here already. We have a formula, but to derive the formula, we have to take this limit, all this limit. So this is what we were doing for number 3, this part right here. And then when we have limit h goes to 0, what happens? So all the h goes to 0. So which one goes to 0? Not this one. This one doesn't have h. Yeah. So it's if h goes to 0, what is this? Negative 3x squared, right? This one is 0, this one is 0. And what do you have on the bottom? X cubed times x cubed. Oh, yes, that's right. Right? And then you have to simplify this, of course. Then you will get the derivative. That's how we get the formula. Yeah? Well, this is not done because you have to simplify the x squared and x cubed and x cubed. Okay, so if we simplify, what is this? Negative 3 over, no, this is x squared divided by x to the 6. Yes. Yes? Did anybody ever take calculus in high school? Yeah. What is the derivative of x to the negative 3? You don't remember? It's negative 3x to the negative 4, which is what we have here. Yeah. So this is the derivation. So yes, will you see it again? Yes, you will see it again. And will the teacher assume that you know how to do it? Yes, he will. Yeah. So you need to know. All right. Let me close the door. All right. Now let's continue. So yes.
Just for curiosity,
Yes.
right?
Yes.
Why wouldn't you expand the x plus h cubed on the denominator since you did it to the numerator as well?
I need to do it in the numerator because I will cancel out the x cubed here. So I need to do it for the numerator because I simplify by canceling the x cubed. But on the denominator, there is nothing that is canceled. So that's why we leave it as x plus h cubed. So there's no cancellations needed on the denominator, right? Yeah. But however, on top, you see here, I have x cubed minus, if I expand this, yeah, then we could do some simplification. That's a good question. Yes? All right. So let's erase this. Now, next one. So that's why we say pre-cal is really important for calculus. It gives you the algebra basis for calculus. Trigonometry will be used more in calculus 2. So you will not see much trigonometry in calculus 1. But calculus 2, yes, you will see trigonometry. All right. So let's continue. Maybe in calculus 1 a little bit, but in calculus 2, I think there is a whole entire 2-3 sections for trigonometry, and then also parametric equations is the whole chapter on it. Yeah, so you need to know tricks for calculus 2. All right, so we talked about rationalizing denominator, right? The same thing as rationalizing numerators, the same idea, so I'm not going to talk about it. The other thing that we could do is simplifying the expression, which is also common in calculus. So let's see, C, and then this is D. But you've seen this before. It's just that I wrote it as rational here. So simplifying expression. This is common in calculus, something like this. Okay. 3 times x plus 2 squared times x minus 3 squared minus x plus 2 cubed times 2 times x minus 3 divided by x minus 3 to the 4th. And you've seen the top one before. We simplified before. How about if I have 3 times 1 plus x to the 1/3 minus x times 1 plus x to the negative 2/3 divided by 1 plus x to the 2/3. Did we do something like this before? For the top only? Yes, we did, right? So forget about the denominator. But we did something like this before on the numerator? Yes, right? Okay. So this is common in calculus also. So, all right. So I'm going to put this is in calculus. Okay. So how are you going to simplify these? Yes. So we factor out the greatest common factor. So factor out GCF first, right? Greatest common factor first. That's right. So what is this? Let's look here. What can I factor out? X plus 2 square. That's right. X minus 3, what is the exponent? Just 1. So 1, there is nothing. So we always factor out the expression with the smallest exponent. Right? The exponent that we choose is the smaller one. So look at these. This is x plus 2 square and this is x plus 2 cubed. That's why we choose x plus 2 square. And then we have x minus 3 square here and x minus 3. Which one is smaller? X minus 3. That's why we only factor out the expression with the smaller exponent. All right, so now, let's see, that's my exponent. Now, what am I left with? 3 times x minus 3. Yes, you're right. Minus 2, that's it? 2 times x plus 2. Yes. All right. Everything divided by x minus 3 to the 4th. Okay. All right. So now, let's simplify the inside here. So what do you have? X plus 2 square. And what happens here to your x minus 3? Cancel one of them? Okay, so I'm going to cancel this and then change this to 3. Okay. Yes, that's right. And what do you have on inside the parentheses? 3x minus 9 minus 2x minus 4. Yes. So 3x minus 9 minus 2x minus 4 divided by x minus 3 cubed. Okay. So how do we continue here? Combine like terms. So 3x minus 2x, x minus 13. Okay. Divided by x minus 3 cubed. Are we okay so far? Can we simplify any more? No, nothing. We are done. All right. Good. Okay, so how do we do number 2? Any common factor. 1 plus x. Now, which exponent do I choose? Which one smaller? Negative 2/3. Yes. So you have exponent 1/3 and negative 2/3. We have to factor out the smaller exponent. All right, so tell me what we are left with. 3 times, okay, this is what we talked about yesterday. 3 times what? 1 plus x, and what is the exponent? 1? Do you remember why it is 1? It's 1/3 minus negative 2/3, right? That's why this is to the first power. So when you factor out the exponent, when you factor out an expression and then you have a common factor, we deduct, we subtract. Right? Okay. And so this is 1. Maybe I should write this as this. And then I should put a note here. The exponent is 1, which is equal to 1/3 minus negative 2/3. I think yesterday I wrote something like this also. Yeah? Okay. Now, what am I left with from the second one? Minus x. Yes. And then this is divided by 1 plus x to the 2/3. All right. Okay, good. Then, what do we have on top? 3 plus 3x minus x. Oh, what about this? 1 plus x to the negative 2/3 and 1 plus x to the 2/3. Oh, yeah, we move it down. So what do I have on the bottom? Yeah, to the 4/3. Yes. Okay? Okay. What do you have on top? Oh, this is easy. 3 plus 3x minus x.
2x plus 3.
Yes. 3 plus 2x or 2x plus 3. It doesn't matter. Yeah. Here they put the number first, so that's why I put the number first. But you could put 2x plus 3. Yes. All right. Okay. I'm actually done with rational expressions. Yeah. I skipped a few things, which is domain of rational expression, but the other ones I actually did. And rationalizing binomial denominator, rationalizing binomial numerators, those ones are the ones that I skipped. Yeah. But I think you can do it. But I'm done with 1.4. Can I clarify anything before we move on? Yes, Andy.
Why should the negative 2 stay to the bottom?
Oh, okay, good question. How do I get 1 plus x to the 4/3 on the bottom, right? Why don't I just keep them separate? So for one thing, what you want to do is to combine these, because these two have the same base, 1 plus x and 1 plus x. So you need to combine these, right? So if you have, for example, x minus 2 divided by x squared, what would you do? Would you write them like this? No, right? So what would you do if you have x to the negative 2 divided by x squared? So you will combine these. So what is this? This is x to the negative 2, and then what do you do to the exponent? Minus 2, which is x to the negative 4, which is 1 over x to the 4. So this is exactly what I was doing. It's just that it is 1 plus x, and this is negative 2/3. Yes, we just did it in one step. So basically this is 1 plus x raised to the negative 2/3 divided by 1 plus x raised to the 2/3. So this is 1 plus x. What do you do to the exponent? Subtract, right? Negative 2/3 minus 2/3, which is what? 1 plus x raised to the negative 4/3. So I write it on the bottom. Make sense? Okay, good. Now, I only have 3 minutes. So I cannot start a new one. Now, for the equations, did Miss Ye talk to you about the equations involving radical? So, did she talk to you about this last time? All right. So, for example, something like this: 2x plus square root of x plus 1 is equal to 8. She didn't have time for that. So did she talk about the quadratic formula? Okay, so until when did she finish? Is it the quadratic formula? Completing the squares? How about this equation? 1 over x minus 1 plus 1 over x plus 2 is equal to 5 over 4. This is a rational equation. Did you talk about something like this? No? Okay. All right, so let me see. I think I'm going to have you guys do this one on your own. Let me see. Okay, so what homeworks do you on Monday? 1, 3, 1, 4. And then 1, 5 is where? Online. Is due Sunday, 11:59 p.m. So the paper that you turn in on Monday is just 1, 3, and 1, 4 because the 1, 5 is portfolio, right? So I just need the homework paper for 1, 3, and 1, 4 on Monday. Yeah, and I will also return your other homework on Monday. Yes? Is it clear? Yep. Okay, and did I tell you what numbers they are?
Yes.
Okay, I forgot what it is, but you guys know because I told you. Okay, guys, have a good weekend. And Monday, I will also give you your take-home test. So you should start working on it. Yeah?
Question for you.
Yes. Let me close the recording really quick. Okay, and then I'll answer your question. All right, so we're actually done with 1.4 rational expressions. On Monday, we will do a little bit of 1.5 and 1.6 and 1.7. All right.